I have all the equations for V and M for different zones. So what do I have here? I should now draw the shear force and the shear diagram and the moment diagram to answer the question. So how to draw them? Basically, guys, you should draw them under the figure, all right? So I will draw them here. So basically, I will assume that this is the diagram of V. And guys, you should pay attention to the force that will change the equation, or the force where I did a cut before and after, which is here, this point load. Alright? Why, guys? Because in fact, in the first cut, I know that V was equal to 2.5 kilonewton, and it is constant for any x between 0 and 2. Now in the second cut, I found that V is equal to minus 2.5, and it is constant from any x between, so let's make it constant, between 2 and 4. So this is basically the shear force diagram. It is here positive, constant positive 2.5, and here it is negative, and it is equal to minus 2.5. Now how to draw the moment using the same method? So I should draw my moment diagram. So let's say this is M, and this is X. So in the first cut, guys, before B, I know that M is equal to 2.5x, so it is going from 0. When x is equal to 0, M is equal to 0, going in a straight line till this point here, which is equal to 5. 2.5 times 2 is 5. So here at B, I have x is equal to 2, so it is 5. And then, guys, if I apply the second cut, I have 10 minus 2.5x, so the slope is negative, and this means, guys, that M will go downward. And you can see, guys, that when x is equal to 4, so if you take this equation, guys, and you apply x is equal to 4, 10 minus 10 is equal to 0. So here, guys, M should be equal to 0. So this is basically how you can draw your shear diagram and your moment diagram. Now, guys, I want to solve the second problem in the slides, and in this case, I have a distributed load. So what happens if I have a distributed load? How can I draw the shear diagram and the moment diagram? Let's see. So here in this example, I have a triangular load applied on a beam that is, it is a simply supported beam. So I have a pin and a roller at the second end, and the intensity of this triangular shape is 6 kilonewton per meter. So what do you think, guys? How many cuts do I have here? I only have one cut through this distributed load. So we said, guys, that if I have a distributed load, you should make one cut through this distributed load. Now, if this distributed load is ending at the end point of the beam, so there's no need to make another cut after this distributed load. However, if this distributed load, like this case, is ending, for example, at 6 meters, you should do another cut after this 6 meters. So here, guys, I have this example. I will solve it in details. Let's do it. So of course, guys, the first step is to find the reactions at this beam. So basically, I have here one reaction. I know that I should have two reactions, but since there is no horizontal force, so there is no horizontal reaction. And I have here another reaction, RB. And I know, guys, that since this is a regular shape, I can replace this distributed load with a resultant force that is equal to the area under this line, or the area of this triangular shape at the center of gravity of this triangular shape. So basically, of course, guys, the center of gravity will be a point here, somewhere here. And so that, guys, the distance between this point and this point is 1 over 3 of the whole base. Now the whole base is 9, so 9 over 3 will be equal to 3. So which means, guys, that this distance is equal to 3, and this distance, of course, from A to this point will be equal to what? To 6, alright? Now, guys, the resultant force will be equal to the area, which is 6 times 9 over 2, which is 27. Okay, so let's apply the first step and find the reactions. So I know from the sum of Fy is equal to 0 that Ra plus Rb is equal to 27. So Ra plus Rb is equal to 27. And I know that from the sum of moment around, let's say, A or around B, so it is the same. So let's find it around B to find Ra directly is equal to 0. That Ra times 9 minus 27 times 3 is equal to 0. And this means, guys, basically that Ra will be equal to 9 kilo Newton. Now, guys, no need to find Rb because, in fact, I will take the left part, so I'm not interested in finding Rb. Now, let's make our first cut. So, guys, this will be my first cut. And don't forget, guys, that this should be x, right? So this is my x here. And I know that this Ra here is equal to 9. Now here, guys, don't forget that since this is the left part, V should be downward and M should be in the counterclockwise direction. Let's start applying my equilibrium equation. So basically, guys, if I want to apply the sum of Fy is equal to 0, what do I have here? I have 9 plus 9 minus V minus what? Minus the resultant force of this distributed load from 0 till x. So I should basically, guys, find also this area right here. So guys, here, I cannot say that it is 9 minus V is equal to 0. I also have a distributed load from 0 till x. So how to find this area? In fact, guys, in order to find this area, I can apply the theory of Thales. So basically, guys, since the whole length is 9, so for the whole length, I know that for 9, I have a height of 6. Now, for x, what do I have? Which height? Alright, so the height should be what? Should be 6 times x over 9. So basically, it is 6x over 9. So this is, guys, how you can find this height right here. Okay, so from Thales theory, so it is 6x over 9, and then, guys, my resultant force, which is the area under this, or the area of this triangular shape, will be, of course, the height, which is 6x over 9, so this is the height, times the base, which is x, over 2. So basically, guys, my resultant force will be 6x squared over 18. X squared over 3. So, guys, this is my resultant force. And don't forget, guys, that this distance right here will be x over 3. And this distance right here will be 2x over 3 because here the base is x. So, guys, don't get confused. Now here I have a base of x, so I should find its height, and then I should apply I should find the distributed load by finding the area of this regular shape. So guys, if I want to continue the equation of sum of Fy, so 9 minus V minus what? Minus x squared over 3 is equal to 0. And this means, guys, that v of x is equal to 9 minus x squared over 3. So this is basically v of x, and I will also apply the sum of moment in order to find my m of x. So sum of moment around x is equal to 0. This means, guys, that if I take m as the positive direction, m of x minus 9 times the whole distance, which is x, plus this f resultant times the distance, and don't forget that this distance is x over 3. So x over 3 times x squared over 3 will be x cubic over 9. So guys, don't forget to multiply this f resultant by the distance from this f resultant to x, which is here the base over 3, and this is equal to 0, and this means, of course, that m of x is equal to 9x minus x3 over 9. So guys, now I have the equation of v and I have the equation of m, so I can draw the shear and moment diagram, as you can see here in the slide. So guys, you should draw v and m using the equation. Now here I only have one cut, so it is only one equation that I should draw it. So of course I should start by 9, because when x is equal to 0, v is equal to 9, and then I will end with 0 here, and then I will end with minus 18, and then here, guys, for the moment I have the equation of 9x minus x3 over 9, which means, guys, that x is equal to 0, m is equal to 0, and then, guys, if you replace x by 9, you will see that m will go to 0 when x is equal to 9.